So, let us talk about the phases of action potential now.
Yeah, well, that is the difficult part. I get confused on the phases all the time.
Let's take an example of a nerve fiber, and to make things easier, let's divide the action potential into 4 phases. Resting phase, depolarization, overshoot, and repolarization. You are well familiar with the state of rest. This is the phase at which the cells are in non-excited state or in the state of rest. From here, the action potential of a nerve fiber will begin from -70 millivolts. Whenever there is a stimulus that causes the generation of action potential, we move on to the next phase, which is known as depolarization. De means reversal. Polar means related to charges either positive or negative. So, depolarization meaning reversal of charges in simple words.
This means that there will be reversal of charges in the cell membrane.
Yes. The negative charge on the inside will move outside and the positive charge will move inside the cell. Can anyone tell me how will this happen?
This will be done by voltage-gated sodium and potassium channels, but majorly sodium.
This is on point. The next stage is known as overshoot. Overshoot is the maximum stage at which the positive charge on the inside of the cell will be at its maximum. If we specifically talk about nerve fibers, this overshoot is at positive 35 millivolts. This is the maximum stage in which sodium channels will get sodium ions inside the cell. After overshoot, there will be repolarization. Re means again and polar means related to charges. This means that there will be again recovery of the old charge that were on the resting membrane potential. In this stage, sodium channels will be closed and potassium channels will be opened. Sodium channels will be closed to stop the entrance of sodium ions and create more positive ions, and the potassium channels will open to get more potassium ions out to remove positive ions from the cell. The process will repeat itself until and unless the cell will come back to its resting stage once again.
I have also seen some graphical representation of this action potential. Can you do that as well?
Yes, obviously. We can understand the onset of the action potential with graph very easily. Let us take a simple graph and keep time in milliseconds on the x-axis and membrane potential in millivolts on the y-axis. Now, keep in mind that the action potential starts from the resting membrane potential, which was at -70 millivolts, so we will start making our graph from here. After initiation, there will be the entrance of sodium ions inside the cell that will increase the positivity of the cell. We call it depolarization, and the graph will gradually increase. Critically, there will be a point of positivity from where action potential stops. This is called overshoot. This is the point where maximum action potential has been generated in the nerve fiber. Now, I want you to remember one more important value, which is known as threshold potential. Threshold potential is the value at which the action potential will properly start. This value is around -55 millivolts. Okay, so after the overshoot, can anyone tell me the next phase?
It was repolarization.
Thank you, Alex. Then comes repolarization. In repolarization, the closing of sodium channels will occur and the cell will go back to its state of rest.
So that's now normal action potential works.
Yes, but for potassium ions, the graph will be made slightly different.
And how is that?
Remember that we talked earlier that in voltage-gated potassium channels, they will only be opened when the influx of sodium will increase and the positive ions will be required to get out of the cell. Right? So, the channels will be opened after positivity is maintained. The graph of opening the potassium channels will look like this. And also note that potassium channel opening is time-consuming, but once opened, they will get the potassium ions out until the resting phase is maintained. So, the graph of potassium channels will look like this. Now let me give you a quick summary of the whole scenario for better understanding. At first, the cell will be all happy and relaxed in the state of rest. Let us call it a resting state. Suddenly, a stimulus will fall onto it and that would lead to the change of the charges in its membrane. We call it depolarization through the influx of sodium ions inside the cell membrane. After that, there will be an overshoot point that would have maximum positive charges on the cell. This will lead to repolarization, in which the positive charge on the cell membrane will be again balanced and comes back to the negative charge or resting membrane potential. And this cycle goes on.
That seems really easy. Is that all about the action potential?
No, Alex, there are more secrets to action potential that needs to be revealed. We need to talk about two more ions involved in an action potential. The initiation and propagation of action potential, and finally now the ions flow will come back to the state of rest, is still left to discuss. We will be talking about these in my next class, so you might have to come again.
Of course, I would love to attend the class again. Thanks for your help.
Watch our medical videos anytime and anywhere. Download sqadia.com app now.